In this episode of the CompTIA PenTest Plus training series, we are going to go through web application attacks. And this is a continuation of the attacks and exploits module in section 4.1, I should say. We were talking about the prioritization and preparation of all of the attacks that we were going to do. In section 4.2, we talked about attacking the network. In section 4.3, we talked about authentication attacks, so attacking users and credentials. And in section 4.4, we talked about attacking individual hosts, so host-based attacks. And in today's video, we're going to be talking about web application attacks. So this is, as the name implies, us attacking web applications, websites, and trying to find specific vulnerabilities that we can exploit in that specific environment. So web application attacks target the vulnerabilities in websites and web services. And you can use those attacks to, extract sensitive data, to bypass any kind of authentication, to gain remote code execution or remote control capabilities, and of course, compromising user sessions. These types of attacks will exploit the weakness in the input validation, so essentially forms, any kind of form that you can input some kind of a data, let's say a search field, or let's say a ticket, a support ticket where you can put in your email and then, write a message saying that this is my issue, whatever it is. These would be the types of forms that you can do input validation types of attacks into, and then authentication types of attacks would work also again inside of those same forms. Or we could use authentication attacks for the other types of infrastructure, other types of, we should say, backdoors, side doors, any kind of portion of the web application that may allow us the opportunity to use authentication or, exploit authentication, hack the authentication mechanism of the website. And that could be a token, for example, or it could be a request that we send to the server, something along those lines. And then we have the management of the session. And so session management also connects to tokens, it connects to cookies, and we could be hijacking somebody's session if we get a chance to actually steal their tokens or cookies or APIs. And of course, access controls. And access controls really talks about the concept of weak access control. So if a web developer or the system administrator, the web administrator, the user admin, right, of that given website or web application, if they set up incorrect access controls or weak access controls, or maybe they didn't even set them up, right? Maybe everything is just accessible publicly when it shouldn't be, and that all falls under access controls, and we would want to try to exploit that so that we can get access to things that we shouldn't have access to. So in this particular session, we're going to be covering these specific attack vectors, these attack techniques and tactics. So it's SQL injection, that has to do with relational databases and trying to steal data from those databases. Then we have cross-site scripting, which has to do with the scripting that is available on the site itself. So if we can take advantage of whatever the JavaScript might be, that might be maybe again misconfigured or incorrectly coded, or if we have the opportunity to even inject our own JavaScript into those web forms that we were talking about, these input forms that we have, to be able to leverage that element of it. Server-side request forgery, so forging the requests that are sent to the server, and if the server is misconfigured and it doesn't allow for, or it doesn't sanitize the requests that are being sent to it, then we can potentially take advantage of the server directly. So when we do things like SQL injection and cross-site scripting, these are things that potentially we could be doing on the client side. So that would be the web browser essentially, right? So the client interacts and communicates with the server. So if the client side configurations or sanitization is not done properly, then we can take advantage of the client side. But there's also the server side, right? So if the client side potentially is being sanitized or they've configured it properly, we can try to take advantage of the server side. And then there's the cross-site request forgery, which would go back and forth between either the client or the server. And then, of course, there's remote file inclusion techniques or local file inclusion techniques, which would allow us access to their file system. And we'll be talking about path traversal and the various tactics and techniques that we can use to exploit those elements of the web application. There are videos that are already exist on this channel that you can actually go and search for SQL Injection or XSS or any of these things. And there are actually videos that already exist that will give you a really strong introduction to all of these techniques and tactics, as well as example use cases. So we'll actually exercise these specific attacks against target machines that were granted to us. I did them on the TryHackMe platform because they allow us to actually attack victim machines or target machines to be able to execute any of these types of attacks and still gain a lot of good experience from it. So this is one of the reasons why I really like TryHackMe, because they allow you to do this without getting into any kind of legal trouble or anything like this. You can actually attack servers and web applications, websites, things like that. So there are videos that actually exist on every single one of these. But of course, we will be going through the practical elements of the CompTIA PenTest Plus training series, where we'll try to do things like this as well. And then at the very end of this video today, we're going to be talking about the various tools that we can use to pull these attacks off. And the most popular one when it comes down to web attacks or web application attacks, web service attacks, is Burp Suite. And Burp Suite, I probably at least 10 videos at this point. I have a lot of videos using Burp Suite, and a lot of our different attack videos that we've done that have to do with attacking web applications, we have always used Burp Suite. Burp Suite is one of the most powerful tools that it would be available in your arsenal, and it comes with a community version that you can download for free without any kind of paid license, and you can do a lot of really crazy things with the community free version. But then there's the professional and enterprise versions of the Burp Suite as well, which just really powerful tool. When it comes down to web application testing or web application penetration testing, just know that Burp Suite is a really big name. It's an industry standard, and if you get really good at it, I promise you, just from Burp Suite, if you get really good at Burp Suite, you will find so many job opportunities available for you. Then there's Zap, which is available through the OWASP people, and this is a web application vulnerability scanner that can also create sitemaps for you and find vulnerabilities that you can potentially exploit. There's SQL Map, which is going to help us with the SQL injection and finding various endpoints or locations where we can do SQL injection. GoBuster, which is a really great reconnaissance / enumeration tool. That's a command line tool that will allow us to find, subdomains, I should say, subdomains, files and folders, directories, anything of the sort that we could potentially find sensitive information in. And then there's WP Scan, which is specifically designed for WordPress, and we'll be talking about that as well. And it's actually a really great command line tool that, again, you can get for free. You can get GoBuster for free, SQL Map, Zap. You can get all of these tools for free, and you can use them to do a lot of great attacks, exploits, or gather a lot of really good information that you can use for further exploitation. For example, with WP Scan, you can actually enumerate usernames available for that specific WordPress website and then try to use any of those usernames to do some kind of a password attack using Hydra, let's say, or using Burp Suite. So a lot of really cool tools. This is actually a really good video. I'm excited about this one. I'm always excited about all the videos that I do, but this one I'm really excited about because specifically we're going to be talking about attacking web portals, web applications, web services, and mainly being that in the current era of tech and just business in general, they are leaning more towards web applications that are hosted either through a cloud service provider, or they will host it specifically on their own physical hardware at a specific location, and they have all of their users logging into that web application remotely from a variety of different locations. So companies in general right now are really taking advantage of the convenience that's available through creating web applications that their employees can access from a variety of different locations, which gives us that vector. It gives us an attack vector to go ahead and potentially exploit and do a bunch of cool different types of attacks and techniques. And again, I'm just really, really excited about this one. So this is what we're going to be talking about in today's video. And of course, as always, there's going to be a quick introduction to Hackaholics Anonymous and how you can go ahead and get access to this notes document and the practice questions that we'll cover at the end of this video. And once you get that note, once you get that quick message, we're going to dive into the contents of this video. To get the PenTest Plus notes, practice questions, and to join a supportive community of like-minded people like you, consider joining the Hackaholics Anonymous membership community. We have 4 tiers: the supporter, the agent, the guardian, and the master. And each tier gets their own Discord server and early access to content. The agent, guardian, and master levels will get exclusive content like line-by-line code explanations for how to create cybersecurity and PenTest Plus scripts, like exclusive downloads that they will get. For example, the notes document for this PenTest Plus and everything that I'm using for the lectures, as well as all of the practice questions and everything else that will go along that will be made for the scripts and everything else that we're going to be doing for the PenTest Plus training series. There will be free pre-made monthly Python automations that have to do with system administration, cybersecurity defense, as well as, of course, PenTest Plus and ethical hacking. And then there's going to be monthly live streams with me every single month, plus so many other things that you would get as a part of being a member of Hackaholics Anonymous in these tiers. To join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@hankhackshackers/join, and you'll be able to join Hackaholics Anonymous. Now, without further ado, let us continue with PenTest Plus. So starting from the top, let's talk about SQL injection. Now, what is SQL injection? To be able to answer that question, the core question is, what is SQL, right? So SQL is the structured query language that is used to communicate with databases, to pull information from a database, a relational database in this particular case. Now, if you don't know SQL, it's going to be a little bit hard to kind of wrap your head around everything that we're going to talk about, because I'm not going to be giving you the absolute basics of how to write a query to query a database, to be able to pull information from a database. But when you see things like this, right, so when you see select asterisk from users, essentially what we're doing is we're pulling everything. So asterisk is a wildcard character that stands for anything and everything. So what we're saying is select everything that you can from the user's database, or the user's table, we should say. Now, in the user's table, there are a variety of different columns, and those columns can also be referred to as fields. And in this case, the username field is what we're most interested in, as well as the password field. So imagine a table, an actual, columns and rows basically. And in the very first column, most likely there's always the ID column. So each username will have their own ID. And then the next column will be the username, and then the next column will be a password that's assigned to that user. And when you try to log into a website, the website is going to go search through all of the databases that it has, and then it's going to run something like this in the background. And then it's going to say, okay, where the username is Hank Hackerson and the password is password, and it's going to try to pull that information. Now, if I exist as a user in that database, then it's going to say, okay, cool, you're here, your password matches your username, cool, I'm going to grant you access, right? So it runs this in the background. Now, if we know that it runs it in the background, especially if you just know that they have username and password field that you can enter and you can authenticate yourself and get into that website, then there's a really good chance that that website has a database. And if you know how to write queries to be able to steal data from that website, or to try to get information from the database that it has, then potentially you can actually get the admin, right? So you can go for the admin user and try to find out what their password is, and then or try to find out what the password of the admin user is by running a query like this. And then if you can actually get that information, now you actually have the login credentials for the admin, and you can go ahead and log in as the admin and then do a variety of things that are just reserved for the admin user. So this is one of the key elements, or one of the key use cases about SQL injection attacks. We're trying to pull data that we shouldn't have access to. Now, let's say the website collects people's payment information because people can go ahead and buy things from this website. So that also means that there is most likely a table somewhere or some kind of a database that exists inside of that website that stores people's credit card information. So you can go ahead and try to steal people's credit card information or any other type of sensitive information, because if you can input your credit card, and then there's an option, right, for convenience, there's an option where you can save your credit card information on the website, and they'll ask you, there's a little checkbox that will usually show up that says, save my information for future purchases, right? And if somebody has clicked that on, that means that inside of the database for that website, credit card information has been stored for that specific user. So this is where it becomes really handy from the perspective of a hacker. If you can actually pull off some kind of an SQL injection attack, then you can pretty much steal, a bunch of data. And very many big websites, like really big billion-dollar companies, have been victims of SQL injection attacks. And this is where you hear, 40 million usernames and credentials and things like that were leaked from XYZ website or XYZ company, and it's because there was some kind of SQL injection attack that was actually pulled off, that it was executed successfully, and the hackers were able to steal all of those credentials. And so if that's the case, the website is now vulnerable, all of those users are vulnerable, and then they have to now, based on compliance, they need to notify all the users that, hey, this is what's going on, this is the type of data that we think was stolen, and go ahead and change your password, and go ahead and change your credit card information, etc., because you don't want your users to actually fall victim to some kind of an attack. And then from there, now you get sued. Now there's a class action lawsuit that goes against that company. So you may have actually logged into or tried to log into something on a website or on your phone even, and then a little pop-up shows up where it says this password was a part of a leak, right? Your password was leaked at some point because of something that happened, so it's recommended that you change your password. And this is why we talk about this concept of really strong passwords, because your password, if your password is a weak password and it was leaked, or even if it's a strong password and it was leaked, that means now there's a free text file somewhere across the internet that it is housing all of those passwords. And the RockU password list is one of those things that actually came from an attack that happened against, I think, multiple companies, but MySpace was one of them. I want to say Adobe was one of them. Capital One got hacked. Target got hacked. There are so many big companies that you just wouldn't imagine would be falling victim to these kinds of things that were already hacked. And I talk about a lot of these scenarios in these kind of like real world examples in the CompTIA Security Plus playlist that I have on this channel. So you can go ahead and learn about all of those if you're interested, to just find out all these different real case scenarios, like real world scenarios that big companies were victimized, and the type of attack that was executed against them. So SQL injection just happens to be one of those tactics that is still to this day a very powerful attack vector that you can potentially exploit, and if you're successful, then you can steal a lot of crazy data. So that's kind of like a brief but in-depth introduction to SQL and SQL injection. And there are videos on this channel that talk about SQL and how you can use SQL just to refer to databases and how to pull information from databases. But then there's also SQL injection videos that are available that you can learn how to execute a specific type of attack. So for example, right, so let's say that you actually know what SQL queries look like, right? So you can go ahead and input something like this inside of the user variable right here. So this would be the query that automatically is sent from the website. So when you try to log in, the website is going to send this query, and in this query it's going to try to pull the username variable, and it's going to try to pull the password variable based on what you just entered into the login form. And if those credentials exist, it'll let you log in. But what you can do is inside of this, right? So we could do it from Burp Suite. We can capture the request in Burp Suite, and then we can go ahead and modify this in the backend and input this in the username field right here. So notice that there's a asterisk, not an asterisk, I should say, a single quote. There's another way, apostrophe, I want to say, I think that's an apostrophe. So there's a single quote, right? And so at the very beginning of this query right here, there's a single quote, which means that if we input this inside of this, it's going to have the closing quote for this first quote. So that's what this is, right? So it's basically saying it's either this, right? So you're checking for either the username or you're checking to see if 1 equals 1. And if either of those things are true, then the website is going to grant you access, which essentially 1 is always going to equal 1. So that will always be true. So if the username that was entered, or if it's just blank, right? You just submit a blank username field, but you have inside of this portion, you have the 1 equals 1, then the website is going to send the query and it's going to say, oh, actually, no, 1 does equal 1. So maybe the first part of this was false, but the second part, the 1 equals 1, is actually true. So this is fine. I'm actually going to allow access for this because this gives me a value of true. These 2 dashes right here turn everything else into a comment. So the rest of this query will not be processed by that database server, and it'll stop at 1 equals 1. And at that point, you will have granted yourself at least the first layer of access where you can try to get in as just a empty user. You don't even have to have a username, because for the user you've now placed 1 equals 1. You can technically do the same exact thing for this portion right here, right? But you would have to remove these dashes and put these dashes at the very end of it, because you want the query to actually still process this piece for the password element as well. So in a really perfect world, for low-hanging fruit, you could do the apostrophe or 1 equals 1 for the user and apostrophe or 1 equals 1 for the password, and both of those technically will return a true value because 1 is always going to equal 1, and so the website will now grant you access without you even having a username and password legitimately to try to get access into something, right? So one of the things that we could do here is we could change the user to admin, and then for the password, we could do or 1 equals 1. And so it could say, oh, for the admin user, yeah, okay, it is true. This 1 does equal 1. So it will bypass the request for a password, and it'll give you access to the website as the admin user. So a very, very powerful technique. It's just that it's very low-hanging fruit. So if the web developers were smart, or if they had any sense whatsoever, they would blacklist this command right here, or at the very least they would just sanitize everything that goes inside of their username password fields so that these types of things don't get processed. So you can't enter an apostrophe inside of the username or password field. It will automatically delete it, or if you try to submit this, it's going to say, nope, that's a blacklisted command and you are now blocked and you report it and things like that. So that would be the ideal case as far as security is concerned, but for hackers, we're going to try it, and if we can try it, then heck yeah, I'll definitely do it. So one of the ways that you can test to see if the username and password fields on a website are vulnerable is you just put a single apostrophe and just press enter, and then see how it responds. And if it deletes it, or if it gives you an error message, and in the error message you get to find some kind of interesting information, then you know that maybe, okay, this website might be actually vulnerable for us to do an SQL injection type of attack. So I gave so much information on this one slide right here, but at the same time, I just want to make sure, in case you don't have any experience with SQL injection, I just want you to kind of understand what this actually means. But I do really encourage you to learn SQL just from an administration and web development, database management standpoint, because it's actually very useful to know SQL. It's very, very useful. And then once you know SQL, then you know, okay, there are all these different ways that I can manipulate an SQL query to potentially grant myself SQL injection possibilities. This is what the previous query that we just did, this is what it turns into once we actually embed that or 1 equals 1 element. So you notice that there was a $user portion that was right here, and that was now replaced by this. And so what this will end up doing is, again, it'll comment out the rest of this, And for the username, it'll just say, yeah, 1 does equal 1 actually. And it'll grant you, at the very least, it'll say, okay, this user, you can access for whatever user. Now, in my experience, for my recommendation, it would be to put the username admin here, or some kind of administrator user, assuming that you've done enough reconnaissance to find out what the admin user's username is. So you would put their username, and then in the password variable, in this piece right here, you would do the apostrophe or 1 equals 1. So that way, it'll say, okay, for this user, 1 does equal 1. 1 is true. So it'll allow you access as that user, because the password technically has been replaced with this little injection attack that we have here. So very, very interesting specific attack type, which is the SQL injection, SQLi. So to be able to fix this, right? So to be able to keep an eye out for this, or I guess I should say, we haven't gone to the remediation element of it. I'm kind of jumping ahead here. There are different types of attacks that you can do with SQL injection. So these are the common SQL injection types of attacks. One of them is the union-based, which is we've done a lot of recent videos on union-based SQLi, which uses the union select element to extract data from multiple databases. So you could have the database where it has just the usernames and passwords, but at the same time, you could have databases that have the username and the address for the user, or the email address for the user, or the physical mailing address or credit card number or something like that. So union select is actually a legitimate SQL query that will allow you to union, meaning combine two different databases together, as long as they share one specific column, which is typically the user ID column or the username column. And as long as they share that same column on both of the databases, then you can say, okay, for this username, I want to select everything that I can from the first table as well as the next table, to see what type of database I can, or what type of data I can extract from that database. So that's the union-based SQLi. Then there's the Boolean-based SQLi, which exploits the conditional query. So for example, this right here. So a true or false value is technically a Boolean response. So Boolean responses would yield either true or false. So if you put an incorrect password, then the Boolean response will be false. You're not allowed to get in. But if you do 1 equals 1 as a part of your query, then the value of 1 equals 1 will actually be true, right? Now in that case, what they're doing in this specific example, they're using and instead of or. And from my experience, or is a better operator, because you don't want to say the username and 1 equals 1, because at that point, both of those conditions have to actually equal true. Well, you want to say this is the username or 1 equals 1. And so for that case, it'll say, well, the username is false or the password is false, but the 1 equals 1 part is true, so I'll just give you that, right? So or is much more functional in my experience. So there are different ways that you can obviously implement the and 1 equals 1, but or 1 equals 1 for the case of SQLi seems to be more functional and more effective, just based on my experience. Then we have the time-based SQLi, which uses the sleep command to confirm injection points. And so if it doesn't sleep for 5 seconds, if it immediately responds, then you know that it was incorrect. But if sleep actually counts, so if it does wait 5 seconds before it gives you a response, you know that it's actually processing this sleep query right here. And that gives you a chance to, okay, now I'm kind of getting a good idea that this was useful, that, this username that I tried to input, it actually processed the sleep 5 seconds, meaning that username was actually right. If the username was false, the rest of it would not process, and so the sleep for 5 seconds would not process, and then you would not be able to go on with the rest of your attack. So using the time-based SQLi is very useful when the website doesn't give you some kind of a response that has information in it that you can exploit. So for example, if it says admin user doesn't exist, or I don't know, something that is actually a response other than incorrect authentication or incorrect username and password or something like this, or if you try to sign up for something, right? So let's say you want to sign up for a username and password, and then you use the admin user, and then instead of the, you can't use that user or whatever, it says admin already exists, right? So if that's the response that the website gives you, now you know, oh, the admin user actually exists. And so now I can do something for the admin user, right? I can try to further exploit that user. So the sleep query inside of the SQL command itself, inside of the SQL statement itself, that sleep query, if it gets processed, then it'll actually give you some kind of a response if the website has been configured to not display any kind of message that will give you other kind of intel or information. So this is what we call blind SQLi, because we don't know. The website doesn't give us the kind of response that would potentially lead to other intel being gathered. The website just doesn't give us anything, right? It doesn't give us a response, error message, success message, nothing like that. So if it's blind and you can't get the error message, then you would use something like sleep so that you can still get the website to at least, or you can deduce, right? You can use deductive reasoning, and when you see that it actually does sleep for 5 seconds, oh, you know what, it's actually processing what I just sent in, which means that the part of my query that I sent in was actually correct. And then you can use that to expand on your intel and potentially get a username and password or whatever information it is that you're actually trying to look for. So there are a lot of different types of SQLi attacks, and time-based is one of them that helps with blind SQLi, and then there's the Boolean-based, and of course the Union-based, and several others as well. And you can just go ahead and find that information by going to, it's inside the Junior Pen Tester playlist where we did the SQLi, the SQL injection examples, and you can just learn more about this concept in that video. Now, everything that I've talked about so far has been around the manual SQL injection, but there's a very nifty little tool called SQL Map that will actually do a lot of that for you. Instead of you having to do iterations of dozens, if not hundreds of different queries and statements, SQL Map will actually just do it for you. And so you'll give it the URL, which is going to be the target.com login PHP, and then the parameters here are the user, admin, and pass. And then in this case, the password has been left empty, right? So it's trying to solve for the password. We're trying to get the admin's password essentially. And then we're going to extract the database and batch it all together so that we can potentially find that information. And this specific tool right here, it automates SQL injection detection and database extraction on your behalf. So as long as you run the command, then it'll do the work for you, and then it'll iterate through hundreds, if not thousands, of different iterations to try to find the information that you're looking for. So it's always good to know the basics of it, the fundamentals of something, for example, SQL injection, and then when you use a tool to do the work for you, you have a much broader understanding, a much better understanding of what that tool is actually doing behind the scenes for you. Now, mitigations against this. So this is where I kind of jumped the gun earlier. So mitigations against SQL injection would be these two things, very, very common. These are very common mitigations. The first one is parameterized queries, meaning prepared statements, meaning the queries themselves should be pre-approved, and the only things that can be processed by the database server should be based on the parameters and the queries that were previously approved and created, these prepared statements. The next one is the sanitization, the sanitizing of those user inputs before they're actually executed. So before the command is executed, before the SQL command, the statement that the website would run to try to pull information, before that executes, the server will go through the command that you're trying to submit, that statement that you're trying to manipulate, and it'll say, oh no, you know what, this or equals 1 or 1 equals 1, whatever, this portion of it is not allowed. We are not going to allow this to actually process, so we're just going to sanitize this statement that's being submitted and remove all of these malicious portions of this code. So from there, it will clean it up, and then it'll submit whatever the clean version of it is that was allowed for the server to process. So sanitization is a big concept when it comes down to any kind of injection attack. It could be cross-site scripting, it could be SQL injection, doesn't really matter. Sanitization is a really, really big concept. Parameterized queries is a really, really big concept, and it applies across the board with everything, right? So you just you want those queries to be sanitized. You want them to be cleaned up and remove any specific malicious element of it so that the attack does not execute, the attack doesn't process. And of course, you want to limit the permissions to the database to prevent unauthorized access, and this is where the concept of access controls comes in. So if you have configured the access controls properly, then it's limiting the permissions for accessing the database with unauthorized access or unauthorized credentials. So moving on to cross-site scripting now. So what is cross-site scripting? And again, in order for us to understand what this type of attack is, we need to also understand what JavaScript is. And I'm not going to give you an explanation of JavaScript because I think it would just take too much time and it's hard to understand it without actually seeing code on the screen. But JavaScript is available through pretty much most websites, if not all websites. They use some kind of JavaScript script or references to be able to get the website to do a variety of different things. Excuse me, sorry about that. So they'll get the website to do a variety of different things through these scripted commands that do a bunch of stuff, right? It's actually usable. It's something that is done in proper web development or just normal web development for the website to have specific functionalities. Now, what we're trying to do as attackers is we're trying to exploit these JavaScript codes that are being submitted, or try to submit our own malicious JavaScript code and use it to steal cookies or to deface the website, meaning just put some kind of malicious statement on the website that their users will see, and you'll try to damage the reputation of the website or something. Defacing is kind of like a glorified graffiti that is done on a given website. I'm trying to find what the other word would be when they do graffiti on a building. What is called, I guess it's called vandalism. I don't know if it's vandalism. There's another word for it, but essentially when you deface a website, you're putting like digital graffiti on the website. And then hijacking user sessions, which falls under session management and a variety of other things as well. So cross-site scripting is you injecting JavaScript into the website and then trying to get the website to do something through that script, because it's a script, right? So JavaScript is a script that has a variety of commands in it. And once that script executes, if there is no sanitization that takes place, once that script executes, then the website will actually do what you want it to do. So that's like a very, very high level overview of what JavaScript is and what JavaScript cross-site scripting actually can be. The common types of XSS attacks would be the reflected XSS. So it would be injected via the URL parameter. So for example, a GET request. Now, again, this is something that we would use Burp Suite for, because Burp Suite can capture a request using its proxy. So you submit a request from a website, and when you submit a request to a website, typically it will do a GET request via HTTP protocols, and it will get you the information that you are trying to see from that website. If you're sending data, for example, usernames and passwords, then the HTTP request is a POST request. And then there are a variety of other types of HTTP requests as well. So when you see these types of requests that are being made, you can modify those requests inside of Burp Suite and do some kind of malicious attack if you wanted to. So doing the GET request would actually be something that would be done using reflected style XSS. Stored XSS is injected into the database. So for example, a comment field, and again, you're injecting it into the database, therefore it's storage, right? If it's inside a database, it's storage. So stored XSS is something that you would try to do in their comment fields, because comments are typically going to be stored in the database of the website. Reflected is reflected onto the web browser. You get to see what the command is doing or what you're trying to do. Stored is something that is being submitted into the database of the website, for example, in a comment field, And a lot of websites, including WordPress and a lot of different types of website platforms that are used to build these websites these days, have really good detection mechanisms for spam comments and malicious comments, and they won't process them. They won't allow them to be stored, and they'll just be alerted, and then you get to go ahead and delete them or choose them to be deleted automatically. So these things are, for the most part, taken care of in most modern frameworks like WordPress. However, if somebody manually coded the website, if they manually developed the website and they didn't use a framework like WordPress with all of its various security elements, then you can try to take advantage of this. You can try to see if the comment field or the comment that you're submitting will actually go into their database, and then from there, the process or the command itself that was inside of the comment field will get processed. That JavaScript code, the payload that you put in there, will actually get processed. Then there's the the DOM-based XSS, which in the browser itself, the DOM-based, I believe it's Direct Object. I forget what it stands for. Let's do a quick search of what DOM stands for here. I stand corrected. It's not direct object, it's document object model. So the document object model of a web page is something that each web page essentially is a document. Like when you access it, it's actually a document. And so DOM-based XSS is done through the client side, and it's a type of XSS that takes advantage of the vulnerabilities in the document or the document model of that web page. So essentially, it's done through the client, being your web browser, where you would exploit the way a web page's JavaScript handles and modifies its own user input, its own document-based user input, which allows the attacker, you, to inject and execute malicious scripts directly into the browser itself. And this is very different from other types of attacks where the malicious payload is directly injected into the server's response. We're actually doing it on the client side. So the way that it works is that you, as the user, you craft a malicious link or inject some kind of payload into a web application's client-side script, and then the JavaScript processes it, right? So the vulnerable JavaScript code actually processes your input and it treats it as legitimate data. The script then manipulates the document object, right? The document object model, by writing the attacker's input into the HTML element using functions like inner HTML or document write. Now, these are functions that are unique to JavaScript coding. Once that happens, the execution is done at the sync level. So now it's actually a part of the document and it gets executed by the browser as a part of the page's legitimate functionality. So you're basically injecting it into the browser, assuming that the browser doesn't sanitize it or the web server doesn't sanitize their HTML elements, right? If it doesn't do that, then the next time that somebody loads it, the next time somebody loads that web page, it executes your JavaScript payload on that user's computer, on that user's client. And so if you were trying to steal the user's token, or if you're trying to log into the user's computer or do whatever it is that you're trying to do, the code will actually do it. That JavaScript code will actually do whatever it is you were trying to do on that user's computer. And so if it's a computer or if it's a website that's accessed by a lot of people for sensitive information, or I think something happened like this in MySpace, like way back when, because MySpace would allow users to write their own HTML code to customize their web pages or their profile pages. And so there was a guy who took advantage of this and ran the payload in his own HTML for his web page, and then by, I think, within a 24-hour period, he had like 5 million followers or something like this, because essentially the code was doing it so that anybody who viewed his page would follow him, and then all of the friends of those people who viewed his page would follow him, and the script would just continue to do, just keep going down all of those usernames, and my friend, and then my friend's friend, and my friend's friend's friend, and then their friend, it would just keep going down like that, and it would just make all of these people automatically follow him. And obviously they detected it, because like within a day, for somebody who's an unknown to get 5 million followers at that time, especially for MySpace, that was unheard of. So when something like that takes place, it raises a lot of eyebrows and alerts go off. And yeah, so, but that was basically an example of this, right? So they did it inside of the HTML of the web page, and anybody who visits that web page, automatically that payload executes, and then it does whatever the intention was for that script. That was a very basic example over here, which basically, so anything that's inside of these two portions right here counts as JavaScript. And then in this case, we're just using the alert function inside of JavaScript. And this is going to be popped up. There's going to be like a pop-up on the screen that says hacked, right? So if this actually executes, if the web page doesn't sanitize the input, then this will execute, and then the pop-up will show up on the screen. And then this is just kind of a way to be like, oh, okay, we can actually launch JavaScript on this web page, on this website. So now we can actually put a more sophisticated script on the website and do more sophisticated attacks, like an actual attack instead of a harmless pop-up. Now, if somebody lands on the web page and this pops up on their screen and they see hacked, they're like, oh crap, and they might panic, and then they might do a bunch of things, and you could scare people and use that as like a fear-mongering tactic or something like that, and make the website lose credibility and the business lose money, things like that. But you can, if you can actually run this and it'll do the pop-up and show this message on the screen, then you know that you can actually do JavaScript on this website, and then from there you can do some kind of sophisticated attack, a bigger payload that does more damage. So using Burp Suite to detect XSS. So Burp Suite again. So you capture a request in Burp Suite proxy. If you don't know how to do this, go watch the Burp Suite videos. They're inside of Junior Pentester. There's a five or six videos that's inside of Junior Pentester playlist that is specifically about Burp Suite and how to capture a request and then manipulate the request. And then you would modify the input fields with some kind of an XSS payload, and then forward the request and observe the execution of the JavaScript inside the actual browser. And from there, you will know that, okay, I can do this. This website allows me to submit JavaScript payloads. Therefore, I can now do something more malicious, right? Or I can try to log into the website using the JavaScript payload when I'm not even supposed to be able to log in at all, and etc., etc. So it just depends on what your goal is for your attack, and then you can just customize your JavaScript payload to do that goal, to execute that goal for you. The mitigations against this would be to first use content security policy, also known as CSP, to block inline JavaScript from being executed. The next one is sanitize all of the user inputs from with proper encoding, so HTML entities, or if you just notice something, and there was an example of this in the Burp Suite videos that we did, where the website would sanitize it automatically and they wouldn't allow you to input anything directly into the web page. So we had to capture the request and then use Burp Suite to modify the request and then submit the payload that we had, because the web page itself kept sanitizing it. The moment that this was input onto the form, it would automatically get deleted. So the web page was configured to delete anything that would be even a part of a JavaScript payload. So from there, we had to use Burp Suite to go ahead and submit it in the background. And of course, use HTTP only cookies to prevent session hijacking, so that people or hackers cannot steal somebody's session cookies based on JavaScript, right? HTTP only cookies, meaning that no JavaScript functions should be allowed to process. It should be only HTTP type functions. And if you don't know what HTTP looks like, I guess I could kind of show you real quick. So if we go to here and then we just right click here and we inspect, what we're going to end up seeing is HTTP code. So let's go look over here. So div, for example, div is like a really common one. HTTP looks like this, right? It starts with this, I guess, less than symbol, and then div, and then it ends with this div right here, right? And then everything in the middle of this would count for this block of code, and then we can expand this, and inside of that, it would be how it works. And then span is another one, and then we can expand this, and we can expand this. And so HTTP and HTML work hand in hand together. And if you use HTTP, then if we go up here, we should be able to only see, this is basically on Google, so it's going to be very, very well coded, and I don't think I would be able to find what it is that I'm looking for. But HTTP goes hand in hand with the HTML. You only want HTTP requests and functions to be processed. You do not want JavaScript functions to be processed. And if there are JavaScript functions that are being processed, you want it to be a part of a pre-approved list. You want everything else to be sanitized so that people cannot do it. So we right here, JavaScript, right? So JavaScript already exists on this web page. So if we click on it, we actually don't see anything. There we go. Okay, so this is a JavaScript block of code or JavaScript document that runs whenever we land on Google and we actually do something. And this should not be modifiable from my end, and I don't think it would be, because again, this is Google. And there's a bunch of other things that actually, no, I think that was like pretty much the only part of this webpage that actually holds JavaScript. There is XJS, which would be also other JavaScript elements as well. So if we go look at this, we can see again. So this is what I mean when I say JavaScript is included in every website, because there are a bunch of things that are going on behind the scenes for the website to do what it does. And it's done through JavaScript. HTML is more the skeleton and the presentation and the structure of the web page, and any kind of actions or activities that are done on the web page are done through JavaScript scripts, JavaScript code. So you don't want JavaScript to be something that a user can just embed or manipulate inside of a web page. You want it to be only HTTP requests that are being sent. For example, get requests, post requests, put request, delete, etc. So those are the only types of things that you want to be allowed, which all fall under HTTP, and you don't want JavaScript to be allowed. Now we can move on to server-side request forgery, which occurs when the attacker tricks a web server into making requests to internal systems. And this would be done when client-side stuff doesn't work. So now you want to take advantage of the server-side requests that are being made. So to exploit SSRF for internal network scanning would be by submitting something like this. So you have the actual website itself, right? And then there is the parameter that we're submitting to it in this case, which ends up being the URL parameter. And a lot of times you can actually see it. You could actually see that in the URL on the browser at the top, that is trying to load another URL. It's trying to pull something else from a different server that they have access to. So when you try to load a page, it tries to load something from a different URL, right? This actually can be done legitimately, and they do this. So what happens in this case is that if we know that it's going to load a URL, we can try to get this target website to load our own URL, and we can put the domain for one of our payloads to be executed, right? So you could actually have a JavaScript, for example, or a Python script or something that you're housing on your own server at some kind of a domain, and you can just give it that as the URL, and then if it loads that means it's actually going to load the script, and the script itself is going to run, and then it's going to run on the server, and that web server will now be vulnerable to whatever the attack is being done within that script. So this specific query that we see right here is tricking the server into accessing sources internally from my, so if I'm running it on my computer, 127.0.0.1 is the IP address for my local machine. It's my local host IP address. So it's saying that, okay, go get whatever this is, whatever this file is, whatever this directory is, and all of the contents of this, go get it, right? Go download it. That's basically what it's doing in this particular case. So it could actually be done from your local machine, where you could just do the local host IP address, or you could have it being on some kind of a file share or Dropbox or something, and from there you can still give it the direct URL of that script and then put it into the server, and the server will be forced to run it if it has not been configured properly against these types of attacks, and then it'll download it and it'll run it. You know what I mean? If it's specifically a script, it's just going to download it and launch it. That's basically what it does. So imagine you visit a link that has a PDF file. So at the end of this, let's say this was admin.pdf. If I visited this link, it would actually load the PDF onto my screen, and I would be able to see it. So this is what we're trying to take advantage of. It's going to load it automatically, and it's going to run it. And if it's a Python script or JavaScript script, then what it's going to end up doing is it's going to run that script. And based on whatever the contents of that script were, the server is now going to be running it locally on itself, right? So it's going to be downloading it and locally running it on that specific server. And we're off to the races at that point. We're going to try to see whatever we can get, right? Now, this is a more advanced SSRF exploit. So this query that you see right here, again, same thing. It starts with the target.com load the URL portion. But instead of pulling something from my local machine, in this particular case, we're going to this IP address. Now, this is actually an IP address that is shared by a lot of cloud service providers. So in this case, it's the AWS, right? It's shared by AWS. And then we're going to this specific path where we're going to pull the metadata, and we're going to get the identity and access management security credentials. And we're trying to make this run on this location to try to leak their AWS credentials if their SSRF is unprotected. So if their SSRF is misconfigured, we're going to actually run this specific URL or this script that's at this URL, this command itself, and it's going to be running for this target right here. So this is more, but I mean, really, when you think about it, it's really not that advanced, because the hardest part about this, or the most advanced part about this, is just the URL and the location of the script and all of this stuff. This is the hardest part about this thing. But apart from that, it's the same exact thing that you're doing. You're just loading something on this target server because it actually allows you to do it. This is available inside of the web browser. You see this portion in your web browser and you're like, oh shoot, it's loading a URL from another source. So let's see if I can just put my own URL to see if it'll actually load that part. And if it does, then why don't I just go ahead and try to get security credentials leaked from these people, right? That could potentially work. You don't know, but you could try it. I mean, there's nothing wrong with trying it, especially if you've been hired to do this. If you haven't been hired, then yes, there's something wrong with trying it. But if you've been hired to do this, then do it. Shoot, see what you can get from them. So mitigations against this would be validating all the user inputs, right? Another way of saying sanitize it. So only allow safe URLs that are available. And in this particular case, it's much easier to blacklist everything else and only have a list of URLs that have been pre-approved for your server to access. That's it. Everything else gets blocked. There's nothing else that can be accessed. Use a deny list for private IP ranges. So, 127.0.0.1 or this 169.254, which is this thing that you see right here. So this is another one of these shared addresses that we were talking about that cloud service providers use, and they store things on there. So, right, you want to deny all of those things. But if you just do this piece right here where you have a whitelist and everything else is blacklisted, you have an allow list and everything else is denied automatically, it doesn't really matter at that point. It just blocks everything other than the ones that are known to be safe URLs. And then you restrict web server access to internal services, which again is kind of another way of saying that it should only be the stuff that we know of, that we want the server to access. Everything else gets blocked. And that's the easiest way that you can make sure that nobody can load anything inside of the web browser and try to access something malicious and then launch it on your server. Moving on to cross-site request forgery. This is where we trick somebody who's already logged in into executing unintended actions or commands on a website without their consent, right? So the example in this particular case would be to transfer. So the image source, okay, so this is a very interesting piece right here. So an image source, and this is kind of like a combination of a few things that we talked about. Image source, this piece right here, is something that's inside of HTML, right? So you have an image that loads on the screen. It's a picture of a cat, right? And so when we can see this, we can say, okay, well, this image source is pointing to a URL on that for that website that is loading the picture of the cat. Now, if that is the case, what if we put something inside of that image source URL, so that every time that they loaded that picture of the cat, instead of the cat image being loaded, it loads this little query right here, where it goes to the bank and we're submitting a transfer request to transfer $10,000 to whoever the attacker's username is, right? Why not try it? And then, of course, the image source HTML ends at the piece right here. So it's literally essentially HTML. This is pretty much what it is. It's like HTML, except we've just replaced the URL of the cat pic to the URL for our request to transfer money from their bank account to our bank account. Now, in this case, assuming that they're loading their bank account online profile, we are sending that instead of loading the bank's logo as the image, I want you to run this. I want you to submit the request for them to transfer money from their account into our account. And this would require that you know what the URLs look like for that bank once somebody is logged in and they're just transferring money back and forth between their own accounts or their relatives' accounts, something like that. So you need to know what that bank's URL looks like when a transfer is requested and they're logged in. And so when that happens, you can then go ahead and just load this into the image source portion of that bank online banking, and it'll do it for every single user that logs in, right? And the bank logo has to be loaded, so every single user will, assuming that they have $10,000, it'll attempt to transfer that $10,000 to you. Now, if the bank has a bunch of different users, instead of doing 10,000, you could just do 10, and you can rest assured that every single person, for the most part, unless they're overdrawn or they're like broke, then you'll be able to transfer $10 out of their account to your account, and all of a sudden you have transferred, 10 million, assuming that they have a million users. You've transferred $10 million. That's not bad, right? It's pretty crazy. So if a victim is logged in into their bank account, this forces the unauthorized money transfer, as we just talked about. So the mitigations against cross-site request forgery would be to use cross-site request forgery tokens to verify legitimate requests. And these are things that can be launched on the screen, right? Automatically, when somebody puts in a request, there's a little page that loads or a pop-up that loads that says, "Are you sure you want to do this?" And it was like, "No, I didn't request this. What are you talking about?" Or the server itself will verify a legitimate request based on its sanitization or its previous parameters, the pre-allowed list of requests that can be sent. Then there's implement same site cookie attributes to prevent cross-origin requests, meaning that it can only be done through the same website that you're on, right? The things cannot be done to an external location. That could be a thing that can be done. Same site cookie attributes could potentially be useful. And this is kind of all just falling under the context of cross-site request forgery. And then we have the enforcing of multi-factor authentication for critical transactions, for example, bank transfers. And it could be bank transfers greater than a certain dollar amount, or just any bank transfer. If somebody's trying to transfer money from one account to another account, especially if it's not their own list of accounts. If it's not their own accounts, that they're just doing an internal transfer and they're sending it to somebody else's account, you enforce MFA, and you don't even give them a choice, where it's like, if you want to transfer money out of your account, you need to go ahead and give us this code that we just text to you. And so that enforces this, and it's impossible for somebody to maliciously transfer money out of their account without that one-time password that was just text to the victim itself. So there are a few different things that can be done to take care of this, and this is kind of one of those really, especially in the example of money transfers, like anytime the hack yields the loss of money, everybody's attention is grabbed across the board. Like if one bank was hacked like this, all of the other banks are notified, and they're like, this is what just happened, and they across the board look at their source code, and they look at their infrastructure and their mechanisms, protocols, all of that stuff, to be like, okay, well, let's make sure that we're secure against this that just happened to XYZ bank. We don't want it to happen against Chase, right, or Bank of America or something like that, because Chase has clients across the globe. They have international clients everywhere. So if something like this launches on every single one of those clients, that's like billions of money that's being transferred to the attacker, and that's insane when you think about it. Okay, finally, we are at remote file inclusion and local file inclusion. So remote file inclusion allows the attacker to inject external scripts, so remotely, right? They're sitting on a different location. So they allow the attacker to inject those external scripts into a web application. So very similar to what we saw in the SSRF, right? It's loading something. In this case, it's loading a file. And so if the file value right here for this parameter, the file parameter that we have, if the value of this could be modified to just load something from an external site, this is considered to be a remote file inclusion. And in this case, it's launching this malware.php as soon as this is loaded, right? And so if you can do this, then whatever this malware.php is going to run on this website, and it downloads and executes the malicious PHP code. Very, very simple. It's powerful, but it's pretty simple. And if this has not been configured to stop this, right? So if this website specifically has not blacklisted everything else, right? If they haven't automatically denied everything else other than what is allowed through their own website, then we can basically go ahead and launch something like this and make it run on this server. That's it. It's not that complicated to wrap your head about. It's just about whether or not that configuration has been done and if the vulnerability exists. And if it does, then wonderful. We can go ahead and run our malware script and do what we want to do. The mitigations against this would be to disable this specific function, which is the allow URL include. Disable it, turn it off, right? Instead of it being on, you just turn it off. So it disables remote file execution, and then whitelist allowed paths, right? So instead of using user controlled input, you just have a specific list of paths that are allowed and everything else is denied. And that's basically it. Again, not complicated. It's just powerful when it can be exploited. You can do a bunch of things when something like this exists. So long as this thing has been turned off and they have a whitelist of allowed paths, everything else is pretty easy to take care of, right? You can't potentially attack this specific web application or web service. Now, local file inclusion allows us to access local files on a server, meaning the stuff that actually is on that server. Now, typically, all servers, I think, I want to say all of them, I want to leave room for, a small percentage not being Linux, but for the most part, I feel like all web servers are Linux based. So Apache, Nginx, whatever, these are Linux based servers. And on Linux, there is a file called the etc password file, and then there's another file called the etc shadow file. Now, the etc password file is kind of misleading because you would think that passwords are going to be in it, but it's not. It's just a list of the usernames that are stored on this one. On the etc shadow file is where the password hashes for all of those users exist. But what we're doing here is we're combining a few different things. So number one, this piece that you see right here, this is considered to be path traversal, right? So when you do ... inside of a Linux or Unix command line, so you do cd for changing directory, and then you do ... and it'll take you up one level inside of the file system. So let's say, for example, when you load on this page, right? When you load on this website, you land at, /www/ http /files and then /load.php, right? Let's say that's the path that you load on when you land here. What you're trying to do is you're trying to move up 4 levels, because technically you were in www, http, and then files, right? And then inside of that location, there's the load PHP. So that's 3 levels technically. So what you want to do is you want to end up in the root. You want to go into the root, which is the very, very primary location of any Linux server. It's that the first ever / and then now you're inside of the root of the entire machine, inside of the entire server. Once you're inside of that root, then you can get into the etc partition, and then inside of the etc partition, you can get the password file. So this initial / is the root. And then when you're in the root, there is etc, there's dev, there is users, a bunch of different partitions or a bunch of different locations, right? The etc partition contains configuration files. And inside of this is the password as well as the shadow file. So the etc /password, etc /shadow are probably arguably the most sensitive files inside of any Linux-based machine. So what we're trying to do is we're trying to first get to the root, and then from there we're trying to get to this location. So the way that we would do this is by a series of .. So I want to go up one level, then I want to go up another level, then I want to go up another level, and then just to make sure that I'm really up there, I want to go up yet another level. So I just want to keep going up until I can guarantee that I'm inside of the root partition, and then from there I want to go into etc password. Right? So this is basically what the attack is doing. I just gave you a very quick overview of local file inclusion, but there is a video inside of the Junior Pentester playlist where we actually play around with this, and we go ahead and execute a variety of different attacks, practical exercises basically, where we use local file inclusion to access sensitive data on a web server. So this is what this is for us on this specific section, but if you really want examples of it before the practical video for Pentest Plus actually is uploaded, which is going to be in a few weeks at least. So if you want to learn about this now, then the recommendation would be to just go check out the local file inclusion video that's inside of Junior Pentester, and then run all of those exercises and find how you can actually run this specific tactic and get access to sensitive files on a web server. So this is what local file inclusion is. Now, mitigations against this would be to use absolute file paths instead of user-controlled inputs, which means this should not be modifiable. We shouldn't be able to do this. There should only be an absolute file path that cannot be modified. That's what absolute means, right? That's basically a list of file paths. That it's another way of saying an allow list and a deny list, right? There are a list of file paths that are allowed to be executed. Everything else is not allowed to be executed. I don't care what the user is trying to do. We're not going to process anything apart from this list that is allow only. And then from there, you can sanitize input, right? Literally, we've been talking about this in every single element. Sorry about the background noise again. If you've been watching any of my videos, you know that my neighbors can be obnoxious sometimes. So I don't know if my voice is overshadowing the background noise, or if you can still hear the motor from the stupid little bikes these guys have. Oh my gosh. But anyways, so sanitizing user input is the concept that we have talked about in every single one of these attack types, because that is just across the board. You don't want these things to be allowed. You don't want this to be allowed inside of a URL. So the instant that it's detected, it immediately gets wiped and deleted. And that was pretty much it for the various attacks that we have for web application attacks. And the tools that we have discussed, at the very least, we talked about Burp Suite, which allows us to do vulnerability scanning and, of course, messing around with the requests that are submitted to a web application. So we can capture those requests, we can manipulate the contents of those requests, we can inject our own payloads inside of them, and then forward them to the web server so that it can process it. Even if on the client side there is sanitization that takes place where they don't allow us to input something into the field, it automatically gets deleted. We can still capture that request, modify it in the backend inside of Burp Suite, and then forward it, and it'll be forced to process it. And this is where the server side sanitization comes in, so that if we can manipulate something on the client side, you don't want the server to process it on the backend. And that's where that element of security is very, very important. OWASP Zap, which is an automated security testing for web application, it's basically a really good vulnerability scanner that's available for free that you can use to create a sitemap. It'll crawl the website for you. It'll try to find vulnerabilities, AJAX vulnerabilities, HTML vulnerabilities, any kind of vulnerability that it can find for you, it will find, and it's really, really powerful. It even gives you severity levels on the vulnerabilities that it has found. It'll give you descriptions on what it found. Really, really cool tool. The next one is going to be SQL Map, which is the automated SQL injection exploitation. So it'll find locations on the website where you can actually leverage, or you can go and manipulate the SQL vulnerability. It can even try to find the database download for you, or try to download a database for you. So very, very powerful tool for SQL injection and just SQL type attacks. And then GoBuster, which is directory brute forcing, but it's more like an enumeration tool. Directory brute forcing sounds kind of like you're actually on the exploitation attack side. GoBuster, in my humble opinion, is more for intelligence gathering and enumeration, not necessarily to brute force anything. So what it means over here is that it's going to brute force the finding of these directories and hidden files in those directories and things like that. But you're not going to access it. You're not going to be able to get into those directories unless you do some other kind of attack. So it's more for intel gathering, enumeration, and finding these hidden files and directories and subdomains and things like that. WP Scan, however, can actually not only just find vulnerabilities on WordPress, but it can enumerate usernames. It can try to find login portals for you. Really, really cool tool. It's just specific to WordPress, the WordPress framework. And WordPress is one of the most popular frameworks that people use to create websites. I actually have some websites that I use WordPress for. And because of the fact that it's open source and anybody and everybody can modify plugins and add their own 2 cents on the vulnerabilities that they found, it's one of those things that there's constant updates that are taking place to actually ensure security of the platform. So it's a very, very popular framework, and it's free. So if you're actually interested in setting up a site for yourself and you don't want to pay for anything other than your hosting and the cost of your domain, then WordPress would be the framework for you. However, as attackers, obviously we want to take advantage of the most popular frameworks, and so what WP Scan is where that comes in. So you can still use GoBuster and Nmap and SQL Map and all those things on any website that's not on WordPress. So I'm not trying to say that WordPress is uniquely vulnerable. It's not. It's just that because it's so popular, there was a tool that was developed specifically for WordPress, and that ends up being WP Scan. So when you see WP Scan inside of a command, for example, if you're taking your exam, when you see it, you can just rest assured that they're trying to scan or try to find vulnerabilities against the WordPress website. All right. Let's do some quick overviews of these tools. So Burp Suite, again, is a powerful tool for testing web applications. And some of the common uses would be to intercept the HTTP request using the Burp Suite proxy, and either the Burp Suite proxy combined with Foxy proxy on Mozilla Firefox, or through the Chromium browser that's available with Burp Suite. And then you would modify the parameters inside of those requests and then forward them so that you can get the website to actually process the manipulated version of that request. You can also use Burp Suite to brute force login forms with the intruder module that comes installed with Burp Suite, and it's available for free using the community version. And you can use it to, feed it a bunch of different username lists and password lists, and it'll try to find the correct combination for you to be able to brute force the login to that web form, that login form. And you can scan for SQLi, you can scan for XSS and authentication flaws. However, scanning for vulnerabilities is not available in the community version. It's only available in the professional and enterprise versions. And I still think that brute force is an amazing tool that everybody should learn, even if you don't have the paid versions. It's just that the scanning of these things are only available for the paid versions of Burp Suite. OWASP Zap is the next one, and it has a command line version as well as a GUI, a graphical user interface. So it's an open source alternative to Burp Suite. It can If you don't have the professional paid version of Burp Suite and you want to scan something for vulnerabilities, then you can lean on OWASP Zap because it's open source, it's free, and it can scan for those vulnerabilities for you. So assuming that you're using the CLI version of it, the command line version of it, this would be the command. So you would do zap CLI and then quick scan, and then you would give it the host itself or the target that you wanted to scan, which is https://target.com, and then it'll find common vulnerabilities automatically. It does a quick scan, so it doesn't do like a deep scan. It doesn't go to try to find a bunch of different types of vulnerabilities for you. It'll just do whatever the configuration was for the quick scan, and you can change those configurations, but it'll just do that quick scan for you against this site or against your target, and it'll give you a nice report onto your screen. I like using the graphical version of Zap because it's much easier to choose all of the options that you want for your scans, and then you get to see the reports onto the interface, and then from there you can export the reports and use them for further investigation. You can still export reports using the command line, but it's a little bit harder to do the more advanced scanning if you're not familiar with the command line. And I mean, if you can use the graphical interface version, it's definitely the preferred version of doing it. That being said, there are versions of computers that you might have access to that they don't have a graphical interface, so you have to use a command line tool. And in that case, it's always good to know about the command line version of any given tool. So for example, Metasploit, or Nmap, let's say, that's a really good one. Nmap actually has a graphical version, and then it has a command line version. Zap is another one of those tools that it has a graphical version and it has a command line version. And then from there, you get to leverage the information that you find, the intelligence that you find, to build a good attack exploit or some kind of an attack vector that you're going to use to go ahead and attack your target. SQL Map, as we've discussed, automates the SQL injection testing and database extraction, and this is a sample command that you can use to find and extract databases, tables from a vulnerable website. So you have to give it the URL that you're trying to attack specifically. So target.com, login PHP, user, admin, password is empty, and then you're trying to get the tables and you want to batch them all together so that you can try to use that information again for further exploitation and for the next layer of your attack. So very simple to understand this tool, especially if you know how complex it can be to do an SQL injection attack. And if you want to know how complex it can be, you can actually go ahead and watch the SQL injection video that's on this channel. And it's really, really useful to know it. But if you don't have to do it manually, then I don't recommend you do it because it can be very time intensive and it can be very stressful because it takes very many iterations to do a proper SQL attack, especially against a website that has been securely configured. So instead of doing all of those hundreds of iterations manually, you can use a tool like SQL Map to do it for you. And finally, we have GoBuster, which is one of my favorite tools for enumeration and intelligence gathering. It'll find hidden directories and files and subdomains inside of a web application or a website. And we're saying brute forcing directories, but brute forcing in my mind is more connected to actually kind of launching an exploit or doing some kind of an attack, not necessarily reconnaissance and enumeration. And GoBuster is for enumeration and recon. So when you do GoBuster using the dir option, you will be looking for directories, right? And so you're going to give it the URL, and then you have to give it a word list. And so the word list in this case is the dirbuster common.txt. So it's going to look for the most common directories that would be available, and it'll give you a list of what it finds. And very, very handy, very useful. And based on the directories that you find, you can go and do further reconnaissance and see if there's anything that would actually be vulnerable for you to exploit. So again, it's doing enumeration and it's gathering intelligence for you. It's not going to be brute forcing the login or the attacking of any of these directories. It's just trying to find the list of the available directories for this specific target domain name. All right, and that brings us to our section 4.5 practice questions. Just like everything else that we've done so far, all of these questions are aligned with the PenTest Plus examination, which means there are the formats of multiple choice. So you get one response that you have to choose. Multiple response is two or more choices that you would have to make. And then there are performance-based questions like scenarios and matching things, or they'll give you a command and they'll say, what would be the result of this command? Or they'll give you a result and then they'll say, what was the command that initiated this result? So the key point that I make with all of these sections is we are forbidden, we are prohibited legally from giving you exact questions that are on the examination. Every single educational platform is forbidden by CompTIA. Forbidden is to provide those questions because we sign NDAs when we go take any CompTIA examination, and the NDA says, listen, if you disclose any of these questions, you are going to get a lot of legal trouble. So I can't give you the exact questions, right? But what I can do is I can give you something close, and then I can teach you how to think and how to take an exam. And that's the thing that I am most interested in giving you, because there are too many questions for you to memorize anyways, and the questions are all random when you take an exam. So they'll give you, I don't know, 100 questions, whatever, depending on the exam itself, depending on which one you take, the number of questions will vary, but they're always going to be mixed up. So you're not going to get the same series of questions, and it's very difficult to remember and memorize the answers to these things. So I would rather teach you how to approach the question, how to eliminate incorrect answers, and find the actual answer. And by the end of this, once you kind of understand what the thought process is, and I'm gonna talk out loud and kind of walk you through my thought process. Once you go through the thought process of these questions, I think you'll be very, very pleased, and you'll have a good understanding of how to approach this thing. And if you don't believe me, you can go to the community tab or the posts tab of this channel and look at all of the screenshots that I've posted from people that have taken these courses, the CompTIA courses that I have, and passed their certification exams, and the people that use the CompTIA courses to get jobs. There was a recent story that somebody got a job at SpaceX using the CompTIA Linux Plus tutorials and playlists that I created. So I'm very, very happy for everybody that is actually studying these things and going to get their certifications and getting jobs and all of that cool stuff. So all of that being said, let us now jump into the slideshow for the practice questions. All right, here we go. Question number 1. What is the goal of an SQL injection attack? To encrypt database tables, to manipulate or extract data by injecting malicious SQL commands. I mean, that's such an obvious answer. To brute force SSH credentials, or to overflow web server buffers. So to overflow web server buffers is more of I would say kind of like a denial of service attack is what this sounds like to me. To encrypt database tables for ransom is ransomware. So ransom is the keyword here. And in ransomware, you encrypt all of their databases and they can't access it anymore unless they pay you the ransom. And to brute force SSH credentials is really more about like an attack to log in for remote control. So the only thing that we're doing with SQL injection is manipulating or extracting data from a database by injecting malicious commands into input fields. So there we go. Next one is, which of the following signs may indicate a web application is vulnerable to SQL injection? So we're selecting 2 here. And the first one that just pops out is the input field that contains or 1 equals 1. Now, in this case, this is actually the command itself right here is incorrect. So I wonder if this would end up being the right answer. Like the concept is familiar, right? We talked about or 1 equals 1, but these apostrophes that they have here, these single quotes, is what's kind of throwing me off. So I'll kind of mark that. Database error messages displayed in the browser, that could be 1, right? So the error messages could actually give us a lot of hints on what we can and cannot do, what we can and cannot submit to that database. And redirecting loops when logging in, that was not it. No. Browser extensions failing to load, that's also not it. So if we're selecting 2 and This one I was kind of sure about. This one I'm definitely sure about. So it would just be these two, because these two are not the answer. So I'm just eliminating these two. And as a result, I would say that it's A and B. So yeah, there you go. What is the purpose of a cross-site scripting attack? So remember, we're doing JavaScript payloads input into the web page. So to inject malicious scripts into web pages viewed by other users. So viewed by other users, this is cross-site scripting, but it's also cross-site request forgery. This is kind of what this reminds me of. To inject malicious scripts into web pages viewed by other users. That piece right here tells me that it's cross-site request forgery, not necessarily me putting JavaScript into the web page. To redirect network traffic through a proxy, no. To send fake MFA notifications, no. To brute force login pages. It could be D, it could be A, definitely not B, and it's not C. I feel most confident about A, because the injecting of malicious scripts is the part that I'm most confident about. This viewed by other users part is what throws me off. So I can only choose one, so I'm going to choose A. Okay, it is A. But this piece of being viewed by other users, that's the part where I'm like, okay, that sounds like request forgery. Like we're trying to get another user to launch it through the web pages that they're viewing. But okay, I guess. And so here's the other thing, right? So you're looking for the most obvious answer. This is also another thing that I will tell you is, if you have to convince yourself as to why a question would, or an answer would be the right answer, that's most likely not the answer. And this is kind of one of those examples right here where I was like, ooh, I mean, I can convince myself that it could be to brute force login pages. But the most obvious out of these four is that first one. So which types of XSS exist in web application attacks? And we want 3 here. So TLS injection, so transport layer security, is more for the encryption of the page. And so we're not going to be doing cross-site scripting with that. Cross-site tracing, DOM-based XSS, stored XSS. So it's definitely A, B, and C, because I remember all of these answers right here. These are actually the answers. Cross-site tracing, I don't even think it's a thing. Maybe it is. If it is, feel free to Google it and search for it and drop it in the comment section below and verify whether or not it actually is a real thing. But if it's not real, then obviously you don't have to do that. But for sure, I know that reflected is one, because it reflects it onto our web browser and we can see what's happening. Stored is what we do with comments, for example, where we submit it to their database, to their storage. And then DOM-based is that document object model where we're modifying the document itself. So definitely A, B, and C. What does a server-side request forgery attack attempt to do? So inject JavaScript via hidden form fields. That would be cross-site scripting, so that's not it. Force the server to make requests on behalf of the attacker to internal or external systems. That is definitely the answer. Exploiting SSL misconfigurations has to do with, again, encryption and the configurations of their SSL. So I'm going to say no. And to perform unauthorized DNS record updates, that's also not it. So forcing the server to make requests, right? Server-side requests, that would be the most obvious. Which of the following could be potential SSRF attack outcomes? Select 2. So we need 2 here. Accessing internal services not exposed to the public. Yeah, that could be one. Enumerating metadata services in cloud environments. That could be one. We actually remember we used that one IP address that was available for a bunch of different cloud service providers. So that's definitely one. Forcing browser extensions to uninstall. I don't even know why that's even a thing, but it's a browser extension, meaning it's on the client side. So that doesn't affect us, or it doesn't apply to server side stuff, because this is a client side attack. But again, it's like, I guess unless it's like a AntiVirus or some kind of security extension, I can see where that would be useful, but it's kind of useless to do this. So tampering with DNS cache entries, or DNS cache entries, whatever you want, however you want to pronounce that. Tampering with those things is also not something that would be done on the server side. I don't believe. I think this is more applicable to our local machine, not necessarily their server. So accessing internal services, yes. Enumerating metadata, yes. So those would be the two answers. What is the goal of a cross-site request forgery attack? So to trick a user into performing unintended actions on a web app where they are on a that's it. To steal cookies directly from the database, no. To inject command line arguments into a web form, no. To redirect the user to an attacker-controlled proxy, not necessarily, but this is like a tricky little answer. It could be the thing, but I don't think that's actually the answer right here. So this is the answer. We're only limited to one. This is the most obvious to me, which is A. Yeah. What is a potential risk of local file inclusion? Okay, so local file inclusion means what? We're trying to pull it locally from the web server. We're not trying to send one of our files from a remote location. So exposing sensitive files like etc password or web.config is on their local file system. So that would be yes. Injecting malware via XSS, that's not what we're doing here. Executing JavaScript on the client side, also not what we're doing here. Bypassing MFA push notifications, also not what we're doing here. So executing JavaScript is the server-side request forgery, or client-side request forgery, excuse me. Cross-site request forgery. That's what C is. Cross-site request forgery. This is cross-site scripting. And then this is bypassing MFA push notifications, which I forget what the one that was right here, but I think that was also part of the request forgery on the cross site. So what is the potential risk is the sensitive files on the local file system. So A for sure. Which of the following are valid indicators that a web app may be vulnerable to remote file inclusion or local file inclusion? So valid indicators that the app is vulnerable. So user input is included in file paths without sanitization. Yes, that is one. Error messages reveal file read attempts or file read attempts or paths. That's also one. CSRF tokens are predictable. That is more for cross-site request forgery. So it has nothing to do with the remote file or local file inclusion. And web application firewall rules trigger on form submissions. And that also is not it. So it has to be A and B. Yeah, okay. Which tool is best suited for automated SQL? You should already know this. You shouldn't even have to go through the tools. It should be SQL map. Automated SQL is SQL map. WP scan is for WordPress. GoBuster is for enumeration of files and folders and subdomains. Wireshark is a network sniffer, and you can look at network traffic and analyze packets in depth, but has nothing to do with automated SQL injection. So SQL map is the answer. Which tools can be used for web application fuzzing, testing, or vulnerability scanning? So 3 tools here. Burp Suite for sure. OWASP Zap, yes. GoBuster for web application fuzzing, testing, or vulnerability scanning. PowerSploit, Responder. It's definitely A and B. I guess it could be GoBuster. Not really sure. I'm gonna say ABC. I'm gonna say ABC. Yeah, it is. PowerSploit is for PowerShell exploitation, and Responder, I forget what Responder was, but it's not for web application attacks. I don't think. I don't remember. I forgot already what Responder was. That sucks. But I don't think it's for web application fuzzing. Responder kind of reminds me of the counterpart to requests that are being made. So maybe that could be potentially web application, but I don't think so. PowerSploit, I know for a fact that it's for PowerShell exploitation and PowerShell payloads and things like that. So here's our first scenario now. It's going to say you visit a login page, or you enter you visit a login page and you enter, apostrophe or 1 equals 1 in both the username and password fields and gain access without valid credentials. So this is an SQL vulnerability that we've exploited here. So SQL injection would be the answer. Cross-site request forgery is when you get the user to run something on their machine. Local file inclusion is where we're trying to get something from the file system of the server. And then of course, SSRF is a server-side request forgery where we're trying to get the server to execute something on our behalf. So SQL injection is what we're doing here. This is a part of an SQL statement. So you need to be able to recognize SQL statements. And in the exam, most likely this is not going to be, in a different font or in green or anything like that. So you do have to kind of pay attention to the details of the question to see what it is. But this is definitely SQL injection. A vulnerable blog allows users to post comments. You insert this JavaScript script right here into a comment. When another user views the page, the alert pops up in their browsers. What was this? This is a reflected cross-site scripting, right? So actually no. So you put it into the comment. So this would be a stored cross-site scripting. I think that's what that is, stored cross-site scripting. It is technically reflecting it onto their browser, but it's stored, right? So reflected actually is when you do it and then you see it. Stored is when you do it and then another user views it and they see it. So that's what would, stored. Okay, great. You test the site that takes a URL parameter and you supply this thing, so 169.254, 169.254, latest metadata, and you receive AWS metadata. So what are we trying to do in this case? Is it a server-side request forgery, local file inclusion, SQLi, or Burp Suite proxy injection? So Burp Suite proxy injection makes no sense because Burp Suite proxy allows you to intercept things, and once you've intercepted them, you can inject something or manipulate the request. But proxy injection is not the correct phrase. This is not a structured query language, so this is not SQL at all. So it could either be local file inclusion or server-side request forgery. Now, what we're doing is we're trying to send something to the server to process in the URL parameter right here. Now, if it was a file inclusion thing, this would say file. So there will be a file parameter. So we're not doing anything with the file inclusion, so it has to be a server-side request that's being made to a URL, right? So remember, requests are GET request and POST request, things like that. So this is a server-side request that's being made, and that's where that goes. Excellent. You brute force web directories using a word list and find admin backup and config.php. So these are locations, right? Locations and folders and files and things like that. And you used GoBuster. So again, it says brute force, but we are enumerating. We're not brute forcing anything. We're enumerating something. And so we would be using GoBuster to find folders and files. SQL map is to find SQL injection vulnerabilities. Bloodhound is when you are inside of a system, mostly a Windows-based system, and you're trying to find your path to elevate your privileges until you become a domain admin. So that's what Bloodhound does. And Hydra is for brute forcing a web application login form. And so this is what Hydra does. But when you're trying to brute force directories with a word list, especially, you're going to be doing it with GoBuster. Excellent. And that's it, my dear friend. So we have officially wrapped our web application attacks, and hopefully you got some value out of this one. This was a pretty long video in our series of attacks and exploits. So hopefully you got some value out of it. I'm sure there are some questions that will pop up in your head. And if you do have those questions, please drop them in the comments section below. If you have any comments to make, please drop those as well. And let me know if there's anything that I can help you with in this specific matter. All of these videos are dropping on a schedule of Fridays, so you should be watching this on a Friday, or they should have at least distributed on a Friday, and maybe you watched it another day or something. But if I'm still uploading these, and if you're not watching this like months later, then the next video is going to be uploaded next Friday, and then the Friday after that, and we're just going to keep going until we're completely done with CompTIA PenTest Plus. And so for next Friday's video, we're going to be talking about attacks against cloud services and websites that exist on the cloud, and just overall cloud attacks. So I'm excited for that one, just like everything else that we've done so far. So I hope you're excited for that one too. Make sure that you like, subscribe, and turn on the notification bell so that you get notified when the next video comes out on CompTIA PenTest Plus. And I love you. So if no one else loves you, Hank Hackerson loves you. Love, peace, and chicken grease. A quick note from Hackaholics Anonymous so that you can know where you can get these practice exams, these practice question slideshows, as well as where you can get the doc that I was using for the lecture and all of that good stuff. And that's all done through Hackaholics Anonymous. So let's get that, and from there I'll see you in the next video. To get the PenTest Plus notes, practice questions, and to join a supportive community of like-minded people like you, consider joining the Hackaholics Anonymous membership community. We have 4 tiers: the supporter, the agent, the guardian, and the master. And each tier gets their own Discord server and early access to content. The agent, guardian, and master levels will get exclusive content like line-by-line code explanations for how to create cybersecurity and PenTest Plus scripts, like exclusive downloads that they will get. For example, the notes document for this PenTest Plus and everything that I'm using for the lectures, as well as all of the practice questions and everything else that will go along that will be made for the scripts and everything else that we're going to be doing for the PenTest Plus training series. There will be free pre-made monthly Python automations that have to do with system administration, cybersecurity defense, as well as, of course, PenTest Plus and ethical hacking. And then there's going to be monthly live streams with me every single month, plus so many other things that you would get as a part of being a member of Hackaholics Anonymous in these tiers. To join, you can simply click the link in the description below, or you can go to our homepage and click the join button there. Or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous.